Day 361 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2962, count subarrays where max element appears at least k times. The difficulty level is medium, but don't even worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums and a positive integer k. Return the number of subarrays where the maximum element of nums appears at least k times in that subarray. A subarray is a contiguous sequence of elements within an array. All right, y'all, that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input nums equals an array of integers 1, 3, 2, 3, and 3. K equals 2. Output is 6. Explanation says the subarrays that contain the element at least 2 times are, we have the subarray 1, 3, 2, 3, which is right here. Then we have the entire input array 1, 3, 2, 3, 3. Then we have this 3, 2, 3 right here. Then we have this 3, 2, 3, 3 right here. Then we have 2, 3, 3 right here. And we have 3, 3 right here. So as you can see, all of these subarrays have the maximum element, which is 3. 3 is the maximum element in this entire input array. 3 is the maximum element, right? It's the largest element. We want all of the subarrays that we can create that has 3 in it at least 2 times, because k equals 2, meaning 3 has to be in the subarray at least twice. So once again, these are the subarrays, right? So it's 1, 3, 2, 3 right here. That has 3 in it twice. Then we do the full array. This has 3 in it 3 times, but remember it says at least k times. So we needed to have 3 at least 2 times. In this case, it has 3 times, but that's fine because it needs to be at least 2. It doesn't have to be strictly 2 times. Then we have this subarray right here. As you can see, 3, 2, 3 has 3 in it twice. Then we have this subarray 3, 2, 3, 3 has 3 in it 3 times, which once again is good because it has at least twice, because 3 is in it at least twice. Then we have 2, 3, 3 right here, which has 3 twice. And then finally, again, we have 3, 3, which is 3 twice. And these are all of the subarrays that we can create with that have the maximum element, which is 3, at least 2 times, because k is 2. But we're not returning these subarrays themselves. We're just returning how many subarrays we can create. And in this case, we can create 6 of them. There's 6 subarrays. There's 1, 2, 3, 4, 5, and 6, right? So we're just returning the number of subarrays we can create, not the subarrays themselves. In this case, it's 6 subarrays that we can create that have the maximum element, which is 3, at least k times, which is 2. So let's go ahead and take a look at example 2, where they might try to throw a trick our way where there are no subarrays that we can create. So in example 2, we have the input nums equals an array of integers 1, 4, 2, and 1. This time k equals 3, output is 0. Explanation says no subarray contains the element 4 at least 3 times. So when we look at this array right here, this input array, we see that the maximum element is 4. 4 is the largest element in this array. K equals 3, meaning we need to create subarrays that has 4 in it at least 3 times. But as you can see, there's only 1 4 in this input array nums, so it's impossible to create a subarray that has 4 3 times, right? As opposed to up here, there were 3 3s and k was 2, so we could easily find 2 3s or an array with 3 3s, or at least 2 3s to create our subarrays. Down here, we only have 1 4 and k equals 3, so it's impossible for us to create any subarrays that have 4 at least 3 times, because 4 only occurs 1 time in this whole array, so our output is 0. So I hope that made sense to y'all. And now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get started. Now, the first thing we need to do is we need to find the maximum element in the array. And if the array is empty, then we could just return 0. But to find the maximum element, we're going to use a guard statement. We're going to say guard let max element equal nums.max. Put the parentheses, then we're going to say else. We can just open up the brackets and we could return 0. Boom. Now we need to create a variable that will store the total count of the valid subarrays. So this is where we are going to store our result or our answer or our output right here, right? So for that, we are going to say declare a variable, we call it ands, and set that equal to 0. Boom. Boom. Now we need to create our left pointer of the sliding window, so we can declare a variable called start and set that equal to 0. And now we need a variable that's going to hold the number of times the max element occurs or appears in the current window. So for that, we're just going to declare a variable called max element in window, just like that. And we can set that equal to 0 to start. Now it's time to iterate through the array with the right pointer of the sliding window. So we're going to say for end in 0 dot dot less than sign nums dot count. We're going to open up the brackets. And if the current element is the max element, we're going to increment its count in the window. So we're going to say if nums square bracket end equals max element, we're going to open up the bracket and we're going to say max element in window. We're going to increment it by saying plus equals 1. Boom. Now we need to shrink the window from the left until the count of the max elements is less than k. So for that, we're going to come outside of this if statement and we're going to say while max element and it's going to be no s, max element and window equals k is equal to k. Boom. So while max element and window is equal to k. Once again, that's going to shrink the window from the left until the count of max elements is less than k. Boom. So then we're going to say if the element being removed is the max element, then we're going to decrement the count. So we're going to say if num square bracket start, hold on, my bad, y'all, equals max element, then we're going to open up the brackets and we're going to decrement the count by saying max element and window minus equals 1 this time. Boom. Then we're going to move the left pointer to the right by coming right here and we're just going to say start plus equals 1. Boom. Now we need to add the number of valid starting indices for subarrays ending at n. So we could just come right here and we are going to say ands plus equals start. Then after all that, we're going to come right here and we're going to return the total number of valid subarrays by saying return ands. Boom. That should be all she wrote. Let's give it a run, y'all. So give it a run. Ooh, look at that, y'all. It's accepted. So let's go ahead and submit it. Make sure it stays accepted after we submit it because we all know how LeetCode can be. Ooh, that's what I'm talking about. 8 milliseconds. Oh, I thought that was 100. That says 10. Oh, man, y'all. We get these numbers up as we continue down our LeetCode journey. Right now, we be 10% of users. Dang, I thought that said 100. But that's all right, y'all, because I feel like this is a good solution that we can all learn from. It's easy to code, it's easy to understand what's going on, and that's the most important part. We need to be understanding the solution that we're writing so we could retain the knowledge and use that knowledge further down our LeetCode journey. So with that being said, y'all, Make sure you get one more look at the code. This is the top half. This is the bottom half. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.